In this second part, the continuation, it says use proportional relationships. And what we're going to do here is we're going to be talking about comparing perimeters and areas. And there's a theorem. It says if two figures are similar and their similarity ratio is A to B, then the ratio of the perimeters is the same thing, A over B. But the ratio of their areas is going to be the A over B, the similarity ratio or the perimeter ratio, square. So when you set up the ratio for the perimeters, you have that the perimeter of the triangle ABC, so let me go ahead and do that. Let me explain that. So the perimeter of ABC. The perimeter is AB plus BC plus CA. So it's 9 plus 15 plus 12, that is 36, compared to the perimeter of the small triangle DEF, which is 3 plus 5 plus 4, and that is 12. So the ratio of the perimeter of the big triangle to the small triangle should be similar. So it's 36 is to 12, which you reduce it by 12, and that would be 3 is to 1. So the sides, if you compare AB, 9 is to ED, because it's AB is to DE, 9 is to 3, as BC, second and third letter, is to EF, so 15 is to 5. As AC, first and third letter, is to the first and the third letter, DF, so as 12 is to 4. When you compare those numbers, at the end when you reduce those fractions, that's going to be 3 over 1. So notice that the similarity ratio is the same as the perimeter ratio, which is 3 over 1. Now the area of the triangle ABC, base times height, in this case this could be the base and this could be the height. 9 times 12 is 108, divided by 2 is 54. Compared to the area of the small triangle, base is 4, in this case, times 3, so base times 3, the height, 4 times 3 is 12, divided by 2 is 6. 54 over 6, reduce, by 6 is 1, by 6 is 9, and see, notice that the 9 over the 1 is the same thing as 3 over 1 square. So just like the property, the theorem have said, that whatever the ratio of the similarity or the perimeter, that would be the same thing square for the area. Okay, so then, in the first example, when they're comparing the triangle HJK, that is similar to the triangle LMN. So the perimeter of the triangle is 30 inches, of the first triangle is 30 inches, and the area of that triangle is 36 square inches. So perimeter is 30 inches, area is 36 square inches. So they're saying, it says find the perimeter and the area of the other triangle, and they're giving us the similarity ratio. They're saying if the similarity ratio of the first triangle to the second is 3 over 4, well, the perimeter ratio would be the same. The perimeter would be 3 is to 4. So if we need to know, if we know that the perimeter of the first triangle is 30, but we don't know the perimeter of the second one, well, 30 is to P, as 3 is to 4. You cross multiply, you get that the perimeter of the second one is 40. And then the area, we know that the area of the ratios, of the similarity ratios, so the perimeter ratios, you just square that. That is 9 out of 16. So if we know that the area of the first one is 36, as you can see here, we don't know the area of the second one. But we know that that should be 9s to 16. So when you cross multiply, the area is 64. So let's try the first problem, number 9. So in number 9, we have to find the perimeter and the area. So we're going to do one at a time. Okay, so let's do the perimeter. Well, we know that the similarity ratio So similarity ratio. It's 21 to 14. As you reduce, by 7 is 3, by 7 is 2. So the similarity ratio is 3 over 2. So if I need to find the perimeter, see here they're saying that the perimeter is 72. What I can do is I can set it up. I can say, well, the perimeter 72 is to the perimeter that we don't know on the other one, as the similarity ratio is 3 to 2. Then we cross multiply. 2 times 72 is 144, equals to 3 times p, which is 3p. Then we divide both sides by 3, and the perimeter is 48. What is unit of measure? Well, that is centimeters. So the perimeter would be 48 centimeters. And now for the area ratio. Well, the area ratio, let me write it on the side. Area ratio. Well, that is the similarity ratio quantity square, which means that you multiply 3 times 3, and that is 9, 2 times 2, and this is 4. So the area ratio is 9 over 4. So when I set up the proportion, I'm going to have, well, I know that 315 is the area of the first rectangle over A, the area of the second rectangle, and I know the area ratio is 9 to 4. Then we just cross multiply. 4 times 315 is 1,260 equals 9a. And then we just divide by 9. So the area of the second rectangle is 140, and this is square centimeters. Okay. Now go ahead and try problem number 10 the same way as I did number 9. Go ahead and pause this video, Mr. King, for about 2 to 3 minutes. Okay, what you were supposed to have done in this problem is first of all set up the similarity ratio and then set up the area ratio. The similarity ratio, you compare the size, so is 8 is to 24 as 1 is to 3. You reduce it by 8 and you get 1/3. And then the area ratio, you get the similarity ratio, you square that, so that's going to be 1 over 9. Then once you have those ratios, what you need to do is, use those ratios. Like for example here, on the first one, I set it up. I have 27 is to p as 1 is to 3. You cross multiply, so p is 81 because 3 times 27 is 81 meters. And the area would be 32 is to a as 1 is to 9, cross multiply, so the area is 288 square meters. Okay, so that was the problem number 10. Okay, you guys, so at this point you can go ahead and start working on the assignment. And if you complete problems numbers 16 and 17, please show this to Mr. King, and Mr. King would be able to stamp your paper as an exit ticket, and you get 10 extra points in that assignment. Okay, so in class, if you finish 16 and 17, show it to Mr. King, and he'll stamp your paper. Thank you guys for being such a wonderful class, and I'll see you tomorrow. Have a good day. Bye.